Hello. Welcome to Grow the Business, Stay in Compliance, One Bank's Journey. This presentation is about extending role-based access control to microservices and APIs. Things we're going to talk about today are banking regulatory demands, an RBAC strategy for API-based apps, and IDP, API gateway, and LDAP solution characteristics. The main pillars of this approach depend on identity-based access management, OpenID Connect IDP configuration, and in particular, some custom claims in an ID token, and ID token metadata for the application. The LDAP provisioning is read by the IDP, and relationships in LDAP are basically how we provision scopes rather than having the user or the application request them. This will also use an OpenID Connect Apogee API proxy, which employs auto-configuration by calling the discovery endpoint on the IDP, as well as protecting the IDP through proxying and some scope injection. The scope injection can be avoided, it turns out, through a new feature in Ping Federate 11. And then at the end of the day, the business API proxies, when people make business API calls, check for the scopes, and that's how the access control is either allowed or disallowed. So as City National crossed the 50 billion in managed assets mark, we had a bunch of increasing scrutiny and requirements from our regulators. No more application-based user management, no more management of users and databases specific to application and that kind of stuff, which we had a lot of. A requirement to centralize that in LDAP or something similar. Also, the ability to centrally provision and, most importantly, deprovision user access is critical and a demand from the regulators. We also have use of role-based access control to manage user application access, which they require, and fortunately, which we use in general. And we also needed to provide a standardized, consistent role-based access mechanism across our entire portfolio, services or not. Our application environment is large. We have hundreds of applications, upwards of 400, maybe 500, or even 600 applications. They're both colleague or worker and customer facing. We use Active Directory for colleagues and Ping Directory for our customers. But we use Ping Federate for both IAM and SIAM, mostly running OpenID Connect, OAuth, and SAML as well. There's significant heterogeneity in the portfolio in terms of user management style and implementation and application age. But fortunately, we're using RBAC for almost all the applications. And of course, there's a digital transformation in progress, driving increasing use of APIs and services across the portfolio. This approach positions the IDP as the system of record for identity-secured calls to APIs, and we have separate colleague and customer identity domains, all of that pretty common. We severely restrict the grant types. We only allow OpenID Connect auth code and client credentials using JWKS app authentication, in which the client app registers their public key with the IDP, and they use a signed JOT to request a token. The validation of that signature is the main mechanism that either allows the token or not. This approach is using OAuth scopes to extend RBAC to the API endpoint access, and we're using Apogee as a resource server. All access management is in LDAP for both apps and APIs, and essentially the core of this solution is that in the same way that a user is a member of an LDAP group representing RBAC roles, that LDAP group is a member of other LDAP groups representing scopes, and that ties the scopes directly to the RBAC role that the user is a member of. This provides us with an audit-friendly access management strategy that supports easy regulatory oversight, which we desperately need. The API management approach for these applications positions the API as a resource server, as I mentioned, enforcing API access. And we use that hardened API gateway as an identity endpoint proxy to protect the IDP. We're using standard API management policies to check quotas, tokens, spike arrest, poison payloads, et cetera. And we're using OAuth scopes to provide coarse-grained endpoint access control. And this approach maps the scopes to the RBAC roles so that members of RBAC roles always get consistent endpoint access. John?
Okay. So, the challenge here was that with OpenID Connect and OAuth is basically requesting the scopes, and having the client aware of the scopes was really not an option because it really depended on the user who was basically authenticating and for which the client was requesting the access for. We needed to be able to essentially identify, based on the client and the user, what exactly could be authorized. And again, as Jack alluded to, it's all role-based access control. So what we needed to be able to do was to, in a sense, customize the scope coming out of the request to essentially say to the client, this is what you have access to. And when we first started down this path, that was a particular challenge. We couldn't, in Ping Federate, customize the scope. Now, in LDAP, it was fairly straightforward to define the structure of what we needed to be able to pull. So we had the roles. We identified the roles, and the roles were tied to the user. So what exactly could they potentially do in the application, what they were allowed to do. But then we needed to be able to tie this to what essentially the client application could do on behalf of the user. And that's where the scopes came in. And so we had a relationship of the roles to the scopes. Okay, so they're effectively nested groups. And so this structure was very easy to set up conceptually in an LDAP structure. The challenge was in how do we translate that back. And again, the challenge was we needed to effectively tell the client what they could do. And this is where we had to do some OGNL to effectively read in the roles, and then based on that, read in the roles of the user, and then pull out the scopes tied to those roles, basically that relationship, and push that back out to the client. Now, at the time, what we had to do was effectively build this out as a claim in the ID token of what the client was authorized to do, and basically submitted that through an OGNL expression to build it into the ID token. And so that essentially is what the ID token looked like when they get back out to the client. So you had the roles, which again tied to the user, the context of the current user that we've authenticated, which is also part of the ID token. And then we added this claim, the scopes, to it that identified essentially what the client could actually do. Now, as Jack said, Apogee was the gateway, okay? And so what we had to do was, in the Apogee gateway, it basically took these scopes and effectively stuck it into its own access control and leveraged that. So it not only was taking the scopes that came in the access token, but it added this to it. So it was essentially augmenting the access token to decide what could the client actually attempt to do. So one advantage, obviously, to the client is that the scopes claim allows the client to understand what it can do. And here I'm talking about the code, essentially. What can I do based on the user's context, basically based on the user that's currently using this client. And those would change because it's tied, again, it's very much tied to the roles of the user, okay, as to what the client can actually do on behalf of the client. So it's not so much that we're asking the client to essentially say, I want to do X, okay? What we're asking essentially is the client wants to do something on behalf of this user, and okay, here's what you can do based on the roles, okay?
So we have a single API proxy on Apogee, which exposes both the authorization and token endpoints. And as I mentioned, we're only allowing the OIDC auth code grant type. The proxy performs basic checks for things like the client ID, API keys, et cetera. And there are key value maps that hold environment variables. Essentially, so this code without modification flows across all our different development environments. And there's an example there of how we put together things like the discovery URL, which this hits in the pre-flow of the authorized call to basically make sure that it's clear about all the crypto stuff in use and all the different parameters set up in the IDP. So it also adjusts automatically if you make some change in your IDP. The very next caller coming in to get tokens will pull up the new stuff. The authorization endpoint queries the configuration endpoint And values are parsed through things like JavaScript policies and snippets in Apogee and cached for performance benefits. And also using JavaScript to set the authorized and token IDP environments per URIs per environment. It also uses the client ID as an Apogee property and redirect URIs that are in the key value maps. And then proxies the authorized and token calls as they come in from the outside. It proxies them back to the IDP and then sends the 302 to redirect the user to authenticate and all that, sending the auth code to the redirect URI on successful authentication. And then from there, we extract the auth code and use a service callout policy on Apogee to make the token post request, and again, putting together URIs so that it's environment agnostic. Of course, we handle errors from missing auth codes. If things break down at some point along the flow, it drops things and does the appropriate backing out of things. The next thing that we did is that there's a Java policy on Apogee, and we use that to convert this ID token. If you remember back to the slide with the red claims, the 2 custom claims, we convert that to a Java object and then use reflection to pull the scopes claim out. And we use an OAuth policy on Apogee to inject that into the access token. Now what's happening here is it's not really changing the access token, but Apogee uses a Cassandra database for runtime, all the runtime data support. And what's going on essentially is that when the client sends that token in Cassandra, there's a list of all the scopes that are allowable. And so if the endpoint you're calling is associated with one of those scopes that you have, then you're allowed access. If it isn't, then you don't. And so it's a little confusing. When we were using reference tokens, which are opaque, there's no kind of conflict. You don't see anything. It's in the database of the IDP and stuff like that either. But with JOTs, you can actually see the scopes in the claim. There is now a feature in Ping Federate 11 where you can programmatically just set the scopes in the access token, either JOT or a reference token, either one. So that's an improvement and clarifies things for developers. There's a little confusion in our environment because we're only using OpenID profile and email as a standard set of claims, scopes being requested. And so that's what shows up in the JOT under the scopes attribute. But you actually have all these other scopes that you saw in that ID token as well. So this new feature of Ping Federate 11 will make this less confusing, cleaner, better. And after that, we validate the token in JavaScript using values from the configuration endpoint, and then return the packets to the calling client. Provisioning can be done at completely automated fashion. This is new work. It isn't implemented yet. But essentially, being a highly regulated company, we can't do things on an email or a phone call. They need to be provisioned. We use ServiceNow. So we really driving everything from ServiceNow is where we're trying to go. So a request for a new application can provision the RBAC groups for the LDAP roles, can configure the LDAP groups for the RBAC roles. And then the OAuth scope LDAP groups are provisioned for the application and its use of the API. And then the RBAC role LDAP groups are made members of the OAuth scope LDAP groups. And this is the relationship John was talking about earlier. We also have to create a Ping Federate OAuth client, token manager, and token mappings. And that can be done through the administration API for PingFed. And through Apogee, we can create the app, and that creates the mapping between the API key and secret to the Ping Federate OAuth client ID and secret, which are essentially the same thing, but the two kind of get locked together. And then drive all this from a user request for access to a particular application. You can go ahead and put them in a role. The roles already exist, and they're already associated with scopes. And so then the users all get, members of a certain role all get consistent access. This is a little difficult to see, but this is kind of a numbered thing. You can grab this off the download and look at it. But this will show you like all the different steps in the auth code flow and how all the pieces fit together. I also have on the last slide, my email address is on there. If you're interested in implementing this or some kind of variation on this, feel free to give me a shout. Any questions? Go ahead. I think it's just, I mean, we could. Ping is relatively hardened. It's not quite as hardened as an API gateway in general. They're intended to stand out there in a hail of bullets and live through it. So that's mostly it.
And actually, from a ping perspective, that's not an unusual use case with a lot of our customers. But basically, I mean, ping federate, we typically expect, obviously, we expect to be behind a load balancer because we're going to operate in a clustered environment. And so you need a load balancer to balance the work across the cluster. And for a lot of implementations, being also behind a proxy is not an unusual use case. I mean, I think one of the challenges we had with this initially, and what Jack's alluding to, the changes reason, was the fact of that we couldn't augment the scopes. Okay, it was very much dependent on the client making the request. So we very much depended on the Java code in Apogee to effectively take, here's the scopes the client asked for and is visible in the access token, but there's this additional stuff that you also need to pass along. And so that did require, there was very much of a dependency on Apogee to basically essentially take the original access token, and then be able, it also had to have essentially access to the ID token to augment what the client could actually be authorized to do. The change that and so we've always had this backlog requirement of being able to change, to adjust from an administrative perspective the scopes. And this was one of the early use cases that actually kind of drove this feature request, and recently we have implemented so that you can augment. And the advantage with that is that now we can essentially change the approach to say, Apogee, you no longer need to do this, look at the ID token and do this, because we're going to give you that in the access token out of the box. Not only what the client asked for, but what we're adding to it, which makes it actually more flexible to use this model with other gateways, okay? Because one of the challenges with this model was always you had this dependency on the gateway to be able to do this. The other advantage is that it still makes sense to put it in the ID token to educate the client to what it can do if it needs it. Okay, so that still remains, I think, a key part of this, of being able to essentially, because again, the client's not making that request, it's dependent on the case of the user. That is in context, okay, that we're trying to essentially augment. So in a sense, it does simplify the implementation. It still requires, i.e. some Ognal, but in a sense, the Ognal has actually gotten simpler rather than more complex. Yeah.
Yeah, in this setup, which system issue client credentials to the application? Is it API gateway or ping federate?
Well, ping federate is the kind of source of truth, and there's a module in Apogee that basically says, honor this external token. So that's kind of what we're using, and that's the same, it's part of their OAuth 2 support, basically, on the Apogee platform. This is the same thing that is injecting the scopes that are pulled from the claim and the custom claim for scopes in the ID token. That's where we convert that token into a Java object and pull out the scopes using reflections. So that piece is essentially being injected into the access token by Apogee right before handing it back to the client.
So what I'm referring to is when I'm registering application
Right.
of a consumer, I'm expecting client ID and secret
Right.
to be issued
Right.
that application.
Yep.
My question is it the API gateway, Apogee API management that is issuing that credential, or ping federate is one issue?
Oh, gotcha. Okay, so there's actually both in play, and they're essentially mapped together. The first thing we do is we set up the app on Ping Federate, get all the different components set up for it, the OpenID Connect policy, all that, and it gets an OAuth client ID and secret from Ping Federate. That stuff is embedded basically into the application setup on Apogee. Apogee also has an OAuth client ID and secret. The two of them are locked together, basically. The external app really only needs to know about the Apogee piece because it's mapped into the implementation. And so that's how that works. The app is really just playing only with the Apogee OAuth client ID and secret. But those two are mapped together. So when it goes to proxy back to ping, ping doesn't know anything about the Apogee client ID and secret. It only knows about its own. So those when the proxy call happens, it has to use the pair from ping federate. Does that answer what you're asking?
Yeah, that's the area that I'm trying to process.
Yeah, I mean, so essentially the challenge here is with the Apogee and the ping federate is that both essentially have a client identification. Okay, they both have that use case, and so you can take depending on how you want to approach the problem. Okay, is you can effectively have it be the same client and effectively one be the master. Okay. Or have two, in this case, two separate clients, and Apogee is aware that there is a separate ID that it manages, but the client's not aware of. So when the client registers, so when that process happens, behind the scenes as part of the registration process, this is actually all being created to tie the two together, okay, through the APIs and Ping Federate and in Apogee. But the client application, okay, is only really aware of Apogee. It doesn't really know that Ping Federate is there. Because again, that was one of the advantages of proxy. It allows us to have this one entry point.
Also, on the return flow, it allowed us the opportunity to grab that token coming back from ping and stuff those extra scopes into it before handing it over, right?
Yeah.
We're getting close to the end here, but I put my email address up there. If any of you, I realize this is a fairly compressed time to talk about something this complicated, but if you're interested, hit me up. I'll help you implement this or some variation like that. I'm fine. Thank you.